Hi everyone, this is Gopi. I am discussing about machine learning approaches for credit card fraud detection. Introduction. The significance of credit card fraud detection. The growing concern in the era of e-commerce and digital transactions. The annual losses in billions for business and consumers. Challenges in traditional fraud detection. The highly false positive rates and missed fraudulent cases. The inability to adapt to evolving fraud techniques. Role of machine learning. They analyze large data sets to identify complex patterns. They provide flexibility, scalability, and a higher accuracy over the traditional methods. Objective of the study. They evaluate and compare machine learning models, logistic, represent random forest and SVM. They measure performance using accuracy, precision, recall, and F1 source. Objectives. First one is dataset analysis. They explore structure, distribution, and challenges of the datasets. Model evaluation. The logistic regression, random forest, and SVM. Performance matrices. They analyze models using accuracy, precision, recall, F1 score, and ROC and AUC. Compare strength and weakness. They evaluate models based on performance, scalability, and computational efficiency. Future recommendations. They suggest potential enhancements like gradient boosting and real-time fraud detection systems. Datasets details. First one is source. The credit card fraud detection datasets from Hegel. Overview. The total transactions uh, 284,807. The fraudulent transactions 492 0.172 percentage. Challenges. The highly imbalanced class distribution. The anonymized features using principal component analysis, pre-processing. The SMOT. The SMOT means synthetic minority oversampling technique onto balanced classes. Future scaling. The minimum and maximum scaling for time and amount futures. Stratified sampling. The injured balance representation of classes in training and testing datasets. Logistic regression. The linear module suitable of for binary classifications, hyperparameter turning using grid search. Second one is random forest. The ensemble method combining decision trees for improved accuracy. The handles imbalanced data sets of effectively. SVM. SVM means support vector machines. The nonlinear classification using kernel functions. They will suit, suited for small to medium sized data sets. Data split. The 90% of data for training and 10% for testing. The stratified sampling to maintain class balance. Performance evaluation. The matrices accuracy, precision, recall for F1 source and ROC and AUC. Performance matrices. First one is accuracy, the overall correctness of the model, limited value for imbalanced data sets. Precision, the property of correctly identified fraudulent transaction out of all predicted frauds, key for minimizing false positives. Recall, proportion of correctly identified fraudulent transactions out of all actual frauds. The essential for detecting minority class. F1 source, the harmonic mean of precision and recall. Balances, the false positive and false and negative. ROCAUC, the area under receiver operating characteristics curve, the measuring module's ability to distinguish between classes at various thresholds. Results and observations, model strength and weakness, logistic regression, the simple and interruptible limited for nonlinear patterns, the efficient for linear separable data sets, random forest, the accuracy and stability, weakness, high computational cost, They handle imbalanced datasets effectively. The provides future importance insights. SVM. The high precision in detecting minority class. The effective of nonlinear classification. The sensitive to parameter settings. The less scalable for large datasets. Conclusion. Logistic regression. The best suited for simpler datasets with linear patterns or random forest. The balanced accuracy and performance recommended for real-world applications. Support vector machines. The high precision for minority class but less scalable for large datasets. Future work. They explore advanced models like gradient boosting and XGBoost for enhanced accuracy. They investigate deep learning approaches for handling high dimensional and imbalanced data. They develop real-time fraud detection system for dynamic transaction monitoring. Fourth one is incorporate domain-specific features and external datasets to improve model robustness. Thank you.